Okay, so with this question, I first want to explain that it is very small on the screen at the moment. And if I zoom in, it does get quite blurry. I'm not sure why that is. But I am going to keep it quite big because I want it to be really clear when we do the scatter diagram. But yeah, the text is a little bit blurry. So the scatter diagram shows some information about the launch year and the launch price of 12 mobile phones. Here is the information for another mobile phone. The launch year was 2016 and the launch price was £660. Plot this information on the scatter diagram. So just as a reminder, how these scatter diagrams work, each one of these is an individual bit of information. So this tells us that in 2010, there was a phone released that was £400. This tells us that in 2015, there was a phone released that was £600, and there was a phone released that was £700 in 2015. So we put our data point on. The launch year was 2016, so it's going to be on this line between 2015 and 2017. And the price was 660. So that's 600. Let's just think really carefully about where 660 goes. Between here and here, we've got £100 because that's 600 and that's 700. There are only 5 squares between these 2 points, which means each square's got to be worth 20. Because if each square is worth 20, then we've got 600, 620, 40, 60, 80, 700. So it does have to be going up in 20s. It's really easy to fall into the trap of thinking it's always going to go up in like 1s or 10s. But if we just had a look, if it was going up in 10s, then this would be 600, 610, 620, 630, 640, 650, and we know it's not 650 because it's labelled as 700. Anyway, if each square is going up in 20s, then if this is 600 and we're trying to get up to 660, we've got 600, 620, 40, 660. And try and be as precise as you can with making sure that's right on the grid lines. So that's where our plot point goes. Now part B says draw the line of best fit on the scatter diagram. Now this question's tricky because it looks like you want to go through the corner. Like this is close enough that you'd think it would go through this corner, but it does not have to go through the corner at all. Loads of the time people say it's got to go through the corner, but that's just not true. In fact, I think if we have it more like here, I think that fits our data a little bit better. I think that's pretty good. Maybe a little higher. People have in their head these rules about it's got to have as many points above as below, or it's got to go through the corner. Those things aren't true. All it has to do is represent the data as best as you can make it. And if you had it a bit steeper or a bit shallower, it's probably fine, just as long as it represents the data. So I think that's okay. I think that's all right. So we've drawn the line of best fit. Describe the relationship shown in the scatter diagram. Now this is tricky. It's just a vocabulary thing. What we can see from this diagram is that as the launch year increases, so as time goes on, the launch price also increases. And there is a specific phrase for that in maths. That is called a positive correlation. A positive correlation. A negative correlation would be if, as one thing increased, the other thing decreased. So if phones were getting cheaper over time, then as the year increased, the price would go down, and that would be called a negative correlation. But we do not have that. We have a positive correlation because as the year goes on, the cost of the phone increases. So there we have it. This is called a scatter diagram. I think it says that at the top of the question. So if you need to study this, that's what you're looking up. Yeah, quite a short question. Hope that helps.